this thing wasn't built to last. Yeah, good on paper, picture perfect. Chase the high too far too fast. Picket white fence but we painted black. And I wish that you would hurt me harder than I hurt you. And I wish you wouldn't wait for me, but you always do. I've been hoping somebody loves you in the ways I couldn't. Somebody's taking care of all of the mess I made. Someone you don't have to change. I've been hoping someone will love you, let me go. Someone will love you, let me go. I've been hoping someone will love you, let me go.
Spend some time, but this time ain't even. I can leave it in the past, but you're holding on to what you never had. It's good on paper, picture perfect. Chase the high too far too fast. Pick your white fence, but we paint it black.
And I wish that you would hurt me harder than I hurt you. And I wish you wouldn't wait for me, but you always do. I've been hoping somebody loves you in the ways I couldn't. Somebody's taking care of all of the mess I made. Someone you don't have to change. I've been hoping someone will love you, let me go. Someone will love you, let me go. I've been hoping someone will love you, let me go. 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 Been hoping somebody loves you in the ways I couldn't. Somebody's taking care of all of the mess I made. Someone you don't have to change. I've been hoping someone will love you, let me go.
Had a great 7-year white knuckle ride, killing time, flying high as I held on tight to you, to you. Did I blow my mind on the wild side, singing hallelujah to him every night with you, with you. And I'm not gonna lie, say I've been alright, 'cause it feels like I've been living upside down. What can I say? I'm surviving, crawling out these sheets to see another day. What can I say? I'm surviving, and I'm gonna be fine, I'm gonna be fine, I think I'll be fine. Ooh, yeah. Ba-da-da-da-da-da. Ba-da-da-da-da-da. Ooh, yeah. Ba-da-da-da-da-da. Ba-da-da-da-da-da. Like a thundercloud in November rain, is the black dog out running wild again for you, for you. Trying to stream my way to a better life, but a daydream crashed like into the sky. Do you? Do you? 'Cause I'm not gonna lie and say I've been alright, 'cause it feels like I've been living upside down. What can I say? I'm surviving, crawling out these sheets to see another day. What can I say? I'm surviving, and I'm gonna be fine, I'm gonna be fine, I think I'll be fine. Ooh, yeah. Ba-da-da-da-da-da. Ba-da-da-da-da-da. surviving, just crawling out these sheets to see another day. Oh, what can I say? I'm surviving, and I'm gonna be fine, I'm gonna be fine, I think I'll be fine.
The phone rings, already know who's calling, but every time it's after 2. It ain't you, with the champagne talking, saying, baby, when you coming through. You like to call me when you're high, end of the party, I'm your guy. Thing is, I do this every night, and I don't wanna come off impatient, but you only call when you're wasted. You only call when you're wasted. You only call when you're wasted. I wait for the day you tell me you'll see me in the afternoon. Don't get me wrong, I love our late night evenings, but that ain't all I want from you. You like to call me when you're high, end of the party, I'm your guy. Thing is, I do this every night, and I don't wanna come off impatient, but you only call when you're wasted. 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 You like to call me when you're high, and baby, trust me, that's alright. 'Cause I will answer every time, but we should be taking these places, and you only call when you're. I don't wanna come off impatient, but you only call when you're. As much as I love when you're naked, you only call when you're. You only call when you're. You only call when you're wasted. You only call when you're wasted. You only call when you're. You only call when you're wasted. You only call when you're. You only call when you're wasted.
Every door was closing on me. You were so far out of reach. Drunk on the night, you got lips like your wine. I got nothing but time for you. Feeling so high on that look in your eyes. I got nothing but time for you. I believe, I believe, I believe, I believe that loneliness is my disease. I believe, I believe, I believe, I believe that you are the remedy. That you are the remedy. That you are the remedy. I didn't have no one to turn to. Yeah, I was circling the drain. But now you show me I can learn to, yeah, how to be okay again. Oh, feeling so high on that look in your eyes. I got nothing but time for you. Oh, I believe, I believe, I believe, I believe that loneliness is my disease. I believe, I believe, I believe, I believe that you are the remedy. You are, yeah. You are, yeah. That you are the remedy. You are, yeah. That you are the remedy. I believe, I believe, I believe, I believe that loneliness is my disease. I believe, I believe, I believe, I believe that you are the remedy. I believe, I believe, I believe, I believe that loneliness is my disease. I believe, I believe, I believe, I believe that you are the remedy. You are the remedy, oh yeah, yeah. Oh, you are the remedy. You are the remedy. You are the remedy.
You say I make you shy, I don't know why. Every time we kiss, it gets better every time. Underneath the lights, you're shining so bright. The tension in the air, you could cut it with a knife. See, I'm just trying to be somebody. You got me in love so deep. No, I don't gotta do these things, but you make me wanna be romantic. You make me wanna be a star. You make me wanna act different. I love you for who you are. You make me wanna run circles around you. So glad that I found you. You make me wanna be romantic. You make me wanna be a star. You make me wanna be romantic. You wanna be romantic, yeah.
all night. See, I'm just trying to be somebody. You got me in love so deep. No, I don't gotta do these things, but you make me wanna be romantic. You make me wanna be a star. You make me wanna act different. I love you for who you are. You make me wanna run circles around you. So glad that I found you. You make me wanna be romantic. You make me wanna be a star. You make me wanna be romantic. You make me wanna be a star. You make me wanna be different. Love you for who you are. You make me wanna do circles around you. So glad I found you. I just wanna be romantic. I just wanna be a star. You make me wanna be romantic.
So, good evening everybody and welcome to the Hopkins Lecture for 2024. Every year since 1978, the University of Canterbury, together with the Canterbury branch of Engineering New Zealand, has invited an eminent leader to speak on a topic of public interest related to engineering and or technology. And we are so delighted this year that Sir Richard Taylor has agreed to give this year's lecture. So Richard, a very warm welcome to you and to Tania and to your family and friends and colleagues who might be here this evening or watching online. My name is Larry Bellamy and it's my pleasure to co-host this event with Andrew Lamb from Engineering New Zealand, who will run a question and answer session after the lecture. Before Sir Richard speaks, I'd like to make some comments about Harry Hopkins, who we celebrate with this lecture. Harry was Head of Civil Engineering at the university for 27 years. Under his leadership, the department rose to be world-class, and we benefit from his legacy to this day. So it's a real pleasure to welcome members of the Hopkins family, and if I could just personally say thank you for your continued support of this event, which is the premier event for civil engineering at this university. Just some very quick housekeeping. If you've got your phone with you, could you just check that it's either on silent or turned off, please? And if you need the bathrooms during this event, please just head to this side of the auditorium and the bathrooms are at the back. Now I'd like to invite Professor Rajesh Dakal, who's the Head of Civil Engineering at the university, to introduce our speaker. Rajesh.
Kia ora koutou. Welcome to this year's Hopkins Lecture. I'm Rajesh Dakal, the Head of Department of Civil and Natural Resources Engineering at the University of Canterbury. And it is my absolute pleasure to introduce tonight's speaker. Tonight's guest hardly needs an introduction. He's a name that is synonymous with creativity and innovation, not just in New Zealand, but worldwide. Sir Richard Taylor, co-founder of the Wētā company and co-owner of Wētā Workshop alongside with his wife, Tania Rodger, established their business in their home city of Wellington in New Zealand. With more than 30 years of experience working in the world's creative industries, Richard is the CEO and creative director of this award-winning company. As a passionate creative at the core of Wētā Workshop, Richard collaborates each day with his colleagues and friends across a diverse range of artistic and technical disciplines. With 380 crew across 7 businesses, the workshop has grown to become a multifaceted, creativity-focused company. Richard has won 5 Academy Awards across 3 disciplines for special effects makeup, visual effects, and costume design. He has also received 4 BAFTAs, 3 Thea Awards, and more than 35 national and international awards for his work within the creative industries. In 2010, Richard was made a Knight Companion of the New Zealand Order of Merit for his service in film, and voted New Zealand Entrepreneur of the Year. And in 2012, he was named New Zealander of the Year. But beyond the awards and global recognition, Richard and Tania have always been committed to giving back to the community. Their charitable work, especially through their patronage of the Little Miracles Trust, highlights their dedication to causes close to home in Wellington. Wētā Workshop has provided the design and physical effects of more than 160 films, numerous television shows, and multiple location-based experiences. Many of you will recognize their amazing contributions to iconic movies such as The Lord of the Rings, the Hobbit trilogies, as well as the Chronicles of Narnia, King Kong, Avatar, District 9, Ghost in the Cell, Mulan, Thor, and Black Panther. So, without further ado, it is my great pleasure to welcome on stage the brilliant Sir Richard Taylor.
Hello everyone, thank you very much for coming along to hear me speak. I'm very pleased to be down here in Christchurch with my wife and an opportunity to share a little bit about what we do. Firstly, I appreciate there's a very diverse audience in the hall, from members of the public through to university students, from the engineering and design faculty, and industry professionals, of course, who are working across a broad spectrum of technical and creative endeavours. Therefore, it's tricky to think how best to speak to everyone in the room so that each of you gets something out of what I say over the next hour or so, without the risk of boring some of you if I go down too technical a rabbit hole for the benefit of a few. Also, there's no doubt that there's many people in the room far cleverer than I am on the subject I'm talking about. And I acknowledge from a technological level that what we're doing is in our workshop is not rocket science. We'll leave that to the Rocket Lab folk who are doing extraordinary things. But in our own quiet way, we have worked hard to find a way to advance the technologies that we develop and use in service to the creative endeavours that we're trying to put out every day. I brought some things with me. I brought a bunch of things with me. I just started packing them last night, and every time I thought that's probably enough, then I thought there might be another question. Once we've finished question and answers, if anyone wants to come up and have a look and ask me questions specifically about stuff that's on the table, please do, because most of it, in fact, all of it relates to what I'm going to talk about with respect to the way that we've combined creativity and technology at our workshop. I'm going to firstly kick off with a show reel that gives you a sense of what we do in our workshop, and then I will spend 10 minutes talking you through the history of our company and more detail, and then I will kick into a speech on the technologies that we use within our workshop to create what we do. So it would be really great if Sierra, you'd be happy to kick off with the show reel, and then we'll carry on from there. Let's hope that's the only error tonight. Yeah. really good at charades if it comes to it. We'll have to do a bit of performance theatre maybe with a face hugger. While we're waiting, Sarah, just let me know when you can fire it off. Oh, good. Thank you very much. So Wētā Workshop, we're best known for our film effects work, but we do a little bit more than that within the workshop, and I'm going to enjoy telling you about it. First and foremost, though, we started off as a design and manufacturing facility, but we also make immersive experiences, consumer products. We do a whole pile of tourism, we have a game studio, and we run a production studio out of the workshop. But first and foremost, we love to think of ourselves as design and manufacture, and we manufacture across 11 different divisions. We call our team a Jack and Jill of all trades mentality because of their ability to move freely across so many different departments. And for the most part, that's how we've managed to keep our team going over all these years. On the peninsula in Wellington where we work is all the infrastructure necessary to make a major feature film, including our children's television production company and the Roxy, which is a cinema that my wife has created. We started off in a very small way in the back room of our flat. 5 years in, we met Peter Jackson and teamed up with him to work on his second movie, Meet the Feebles. On to Brain Dead, still recognised as the goriest zombie horror ever made. But it was on Heavenly Creatures, while Tania and I were doing the physical effects, that we ended up purchasing our first computer, a silicon graphics computer. But today, Tania and I solely own Wētā Workshop. We have 400 people in our team. Onto a multitude of movies until we ended up on Hercules and Xena for 7 years. And little did we know, of course, that just around the corner was the Lord of the Rings. We opted to look after our part of the design, armour, weapons, creatures, miniatures, special makeup effects and prosthetics. So quite a big bite of the project. Only 1/8 of our staff had ever worked on a film or TV show before, and the average age of our crew just 22 years old to work and make all the things that we did. We were very fortunate to collect some awards for our colleagues back home, and that was a nice exclamation mark at the end of a major project. Since finishing on Lord of the Rings, we've worked on over 160 feature films, sometimes just for a few months, other times for many years, depending on the scale of the production. And this gives us an opportunity to interact with an amazing group of creators from around the world, whether they be visionary directors, producers, or art directors. And we get to work on some really fun stuff. Back into Middle-earth, on Lord of the Rings, we had 3.5 years of pre-production. On The Hobbit, just 7 weeks. Only made possible because coming out of Lord of the Rings, we started investing very heavily in robotic manufacturing. And that was an ability to complement the hand-skill creativity within the workshop with a level of technology. But that technology has boded well for us because projects, the budgets get ever smaller, deadlines ever faster, expectations ever higher, and turnarounds ever quicker. And it could be argued that had we not started to complement our manufacturing hand skills with technology, that we'd actually still be able to stay in business at the scale that we are. And the beautiful thing about this is it means that we can run multiple projects in parallel, and it's given us the ability to hire a different ilk of creative, such as many people that might be in the room today. And of course, it gives us a greater chance to work with some really spectacular clients from around the world that want to bring their jobs to New Zealand. We also run a production studio where we're focused on work for the future metaverse. We're working with some really amazing clients at the moment, including Jay Chow. We have a burgeoning robotics division, and I'll talk about this more in my speech. And this is an aspiration to create humanoid robots for the theming industry off the back of our lifetime of working in animatronics. And I hope that I can inspire some people through what I talk about. We run a consumer products division and have done for 26 years. I have a great love of collectibles, as my office can contest to. And the same team of people that work with me in the movies and help Tania and I also work making collectibles. And we've become well recognised for making some of the finer high-end collectibles in the world, which is a really lovely thing. This took us into China 26 years ago, where we partnered with this wonderful gentleman, our dear friend Fred Tang. And we've gone on and run a lightweight chainmail making company, made public art sculpture, run a bronze foundry, and even built full-size props, including Lancaster bombers in China. I go to conventions every year. I only do one in Comic-Con in San Diego, but it's a chance to catch up with friends and launch new projects. We run 2 retail stores, one in Wellington and one in Auckland, called the Wētā Caves. And because of the popularity of this, it inspired us to open our first tourism offering, Windows into Workshop, where people come and discover and learn about everything that we do within our facilities. A desire to try and inspire young kids to think about the creative industries as a possible future. Pukeko Pictures is our children's television production company, set up to make highly inspiring educational television for kids. We've done the first ever co-production with China through our television in 72 half hours of Thunderbirds Are Go. We publish our own books, and to date we've published 19 books about life on the workshop floor and the films that we do. Stardog's an endeavour that my wife and I set up at the beginning of our career to try and inspire young people within our workshop to start their own art collections and launch their own IPs. The most significant is the World of Dr. Grawborts, invented by Greg Broadmoor, an alternative retelling of the Edwardian universe through publishing, high-end collectibles, a travelling art exhibition that goes around the world, and but most importantly, we made the first ever game on Magic Leap in mixed reality, and this was a company that I was a founding board member of for 8 years. We're right now doing our new game, Tales of the Shire, which is a cozy Sims game, which will be launching soon, and we're excited to see what the public think of what we've created. We also do immersive experiences. Some of you may have been to Gallipoli, the Scale of Our War. This is the seminal project in my working career, and over 4/5 of our country's population is now visited. We do travelling exhibitions and bug labs 10 years across the world. We also have built, we've designed the actual building and then the fit out of the traditional Chinese medicine museum in Zhuhai in China, the largest medical museum in the world. And we've also created the interior fit out for the largest pavilion at the Dubai Expo, following the story of mobility and seen through a regional lens, including creating 3 hyper-realistic 8x life-size characters. Through COVID, we stayed busy by working on the world's largest duty-free shopping mall, and this took us up to Hainan Island in Haiku and created the largest immersive experiential room in the world at this point. And also in France, a very intimate exhibition called Le Quemois, and doing the Pounamu pathways down the west coast of the South Island. Most excitingly though, we've created our own LBE in Auckland called Wētā Workshop Unleashed, an effort to demystify what we do and inspire young kids to think about doing it as well, and hopefully through this experience leave a legacy of the creative arts in our country. And then finally, we do public art, sculpture and commissions, giant aeroplanes, fully working full-size tanks, eagles in the local airport, statues in Trafalgar Square, statues in Hamilton Town Square, and whether we're building our own sculpture park or we're putting giant robots in people's gardens or 8-bit sculptures in people's lounges, whether it's eagles attacking mowers or we're creating rugby memorials, war memorials, or film memorials, that basically makes up the wonderful and wacky world of the weekly life at the ever wobbly Wētā Workshop in windy Wellington. And how's that for alliteration? So I've had our editing team cut together a little slideshow. The images won't correlate at all to what I'm talking about. I wasn't that clever and didn't think I could time it out that well. At the end, there is a Q&A. I might run into it a little bit, or I may even fall short of the slides I've put together for the Q&A. You'll just have to bear with me, but we'll give it a go as well as we can. So we have been making a manufacturing career in the creative industries of the world by pairing our hand skills with our ever-developing use of relevant technologies. And maybe most prevalent thing that has helped us to stay in business this long, outside of the passion, tenacity, and talent of our crew, has been our desire to innovate new methodologies. If the core attribute of the creative is to remain inquisitive, always observing, never just looking, then the creative minds that are my colleagues and friends at work are always looking for the best way forward, how to hit that challenging combination of little time and exceptional results. Pre-LOTR, we were predominantly a hand-skill model-making and craft-based workforce. Today, approximately 60% of everything we manufacture is in some way assisted through some form of automated technology. In the same building, we have colleagues working side by side where one may be using a tool for daily use, such as skiving vegetable tan leather, which can be found in the hieroglyphs of ancient Egypt, while others are working on the most relevant software and cutting-edge technologies as it pertains to our work. We purchased the first commercially available 3D printer we could find on the market over 20 years ago, using a sizable amount of the profit we'd earned of 7 years on LOTR. This was a 3D Systems Envision SR2. I felt certain that this newfangled technology was going to challenge the world for us, and appreciated that whatever the cost, we had to jump on it as soon as possible. So buying this machine was an extraordinary opportunity to explore this unique and new technology for us. Fortunately, it ran really well for a few months and generated a high level of confidence that this was a technology to advance our endeavours across a number of disciplines within the workshop. Ultimately, there was a mechanical issue which required the first visit from the repair guy who had to fly down from Hong Kong. There was a clause in the purchase agreement that we weren't allowed to tinker with it and try and fix it ourselves, which of course, as any Kiwi would, we were keen to do, without the risk of breaking warranty. All good for the first year while there was a maintenance contract in place and we could get this chap out to get the printer running, but quickly became very expensive flying him down to fix this or that after the maintenance contract ran out. I can almost feel Tania nibbling on her nails from here relative to how nerve-wracking that got for us. Ultimately, our only option was to retire it. So, and that's a polite euphemism I've used there, retire it. So before putting it out to pasture, we stripped it down and learnt how it operated and started building our own. For the next 10 years, most of our 3D printing was achieved on 2 home-built printers. Pietro Marson, the head of our animatronics at the time, built 2 ABS printers that went through their own evolution, ultimately becoming fully viable when he thought to include them in temperature-controlled boxes by which to reduce thermal distortion and layer separation, of which those that are into 3D printing can appreciate are an incredible challenge. In fact, amongst many other things, the bodies of the Gallipoli soldiers at Te Papa were printed on these machines. A few years later, we were brave enough to dip our toe back into the commercial 3D printing game and purchased an Object Eden resin printer. It was with this machine that I fully appreciated that the adoption of technology could actually make money through labour savings. It may seem very obvious to most of you, but at the time it had taken me a long time for this to dawn on me and Tania. The Object Eden cost a mighty $250,000, which for us was a huge sum of money. but could replace the cost of the investment we had made in it every 6 months due to the labour savings it was able to produce. What once would have required extensive hours to hand make could now be efficiently produced via additive printing. Naturally, there was a deep concern within our crew that this early adoption of this technology would put people out of work. But in fact, it has been entirely the opposite. The investment in technology has amplified how many projects we can run in parallel and therefore increased our hiring needs. Also, the type of people coming out of schools, polytechs and universities have been noticeably changing over the past 20 plus years. It's becoming a rarer thing today to interview a young graduate that still has an interest in making physical models, working with their hands, or desiring to be on the practical craftsmanship side of the process. Far more predominantly, we are seeing young graduates armed with an extraordinary capability and interest in digital technologies. It was therefore critical that we adapted our processes and altered our recruitment to complement this. A huge benefit to us has been the Victoria University Postgrad Future Thinking course run by the ever-extraordinary Ross Stevens. He is specifically encouraging his students to think as laterally as possible regarding the utilisation and innovation of additive printing and other manufacturing technologies. We have an intern program with Ross and a number of the people who have joined us with a high level of skills that we require have come to us due to Ross's influence and mentorship. So just to round out our 3D printer decisions for those in the room who are more interested in this side of things. The largest printer we have had the opportunity to use by renting it for a year was the Massivit, a UV-cured resin gel printer with a bed size of 1.8 metres cubed. And you will see a number of larger-than-life historical Chinese characters in the slideshow above me. Well, that's uncanny, almost, whose bodies were entirely printed on these. We bought into a 6th share of a Stratasys 850, and that might speak to how expensive they are. We were only able to afford a 6th share of it, which we then shared with other faculties, universities. And this has been instrumental in developing our clear-coloured resin printing, with the most significant examples of this being the eyes that we printed. And I've actually brought a few examples of the eyes down with me. Tania used to create all of our eyes, and we were pretty proud of the eyes we could physically make. And in fact, the eyes and the Gallipoli figures have been made physically in the workshop. But now we're able to print them and get them to the point that we can exactly replicate a human eye, right down even to the limbus line that exists between the iris and the white of the eye. Very, very exciting. And although the Object Eden that we had purchased was our go-to workhorse for a number of years, ultimately the company priced themselves out of our affordability as their resin was proprietary and simply climbed in price so much that we had no choice but to abandon this machine and look for alternatives with cheaper disposables and resins. We found this in the form of the Chinese SLA Z Rapids, of which we own 2. These run 24 hours a day and have done so for the past 8 to 10 years. The resin is non-proprietary and cost-effective. The machines are big enough to print a 2.4 times human head mould, so great for our larger-than-life, hyper-realistic human figures, of which you may see some in the video. We also use FDM, that's fused deposition modelling, and FFF, which is fused filament fabrication printers, such as the Bamboo X1C, the highest recommendation I can make to anyone trying to buy into low-cost printing at the moment. And the uses for this is quick turnaround prototypes, stunt and background parts and moulds. We also use LCD, liquid crystal display printers, and we have the Frozon Mini, Mighty and Megas, the Elegoo and the Saturn III, for those people as nerdy as me about 3D printing. And we use these for our collectibles masters, our hero masters, our flexible parts, and light diffusers. We use digital light processing printers in the Nexa XIP desktop, and these we're using for animatronics and hero stunt end-use parts. We use SLA and stereolithography printers, and we use the Z-Rapid ISLA 660. And not in-house, but we still use prolifically, is the MJFs, the multi-jet fusions, and these are HPs for the 4200 and the 5200 series. And we're doing this for our hero and stunt end-user parts. And it's worth mentioning at this point the high-level evolution of our 3D manufacturing. Our original usage of 3D printing was almost exclusively to produce mold masters from which we would then mold and cast into more resilient materials that we felt confident could deal with the rigors of on-set life. In 2020, a ZBrush update introduced new features, greatly enhancing our mold-making capabilities, which we first widely utilised for hobbit legs, of which I brought some down there. Hold one up. You must come down and play with hobbit legs afterwards. I can actually throw one to someone. Orc prosthetics and a multitude of weapons. A Houdini-based automated mold jacket creator was also developed in 2022, which we utilised to create the first fully 3D printed creature suit molds for a New Zealand movie called The Tank. Our FDM filament printer fleet of 20 machines was fully upgraded to the Bamboo X1 printers in 2023, greatly increasing speed and accuracy, enabling overnight and same-day prototyping and mold printing, which is brilliant for prototyping. Print end-use stunt props and costume pieces to go on set, primarily using the ColourFab VariAssure TPUs. And TPUs have really changed a lot of what we're doing, and I've got some great examples of TPUs on set. We predominantly think about 3D printing as being non-flexible, but you can appreciate as soon as you start being able to print in flexibles, you no longer have to transfer your masters that have been printed into elastomeric polymers. Digital mold making has allowed us to quickly prototype and fine-tune attachment mechanisms and optimal thicknesses for our animatronic skins. And you can see there's a great example of a 3D printed mold into which we've poured a silicon skin around a core or a mandrel to generate a very fast turnaround product that previously could have taken us many, many days to produce. We added a Nexa print to the fleet in 2024, enabling printing of both high-resolution, in-use hero props and costume pieces, soft mold masters acting as silicon mold replacements, and highly durable engineering materials at overnight speeds for in-use animatronics and robot parts. And I brought along this wonderful print here, where we've actually printed a flexible mold from which we then can cast a little replica, and that's the head of our 3D department. That's the head of our 3D department, actually. So with this, we can now produce an entire 1/6 scale figure in 24 to 48 hours. With this, we've started to replace some product lines with printed paint and mold masters, no longer molding and casting in-house. Produce parts for lost wax casting, and we've discovered we can dye resin to create custom light diffusers and prop pieces with 3-dimensional depth of colour for both film and location-based experiences. And there's a great example. That's a flower that's been printed, and this is for the bouquet that's been held by the soldier in the Le Quenoir exhibition. And we have tinted this in a dyeing process using RIT dyes that creates a beautiful diffuser in the petal pattern of the actual piece. And recently, the addition of the Mamaki printer this year has us looking more deeply into colour printing end-use products for both film sets and consumers. The Mamaki 3DUJ553 came to us via Olaf Deagle at the Auckland University Additive Printing Department. Olaf may be the most passionate advocate of 3D printing we have in the country. One of our team, Cade Lee, has been developing an AI tool to assist with the complex analysis involved in getting the best that we can out of this machine. And I brought along these wonderful little things that some of you may find interesting, and these are his AI tests where he is actually working at pixel level control so that he can print something such as this, which is the interior representation of that gun over there. And he's now even managed to, here's a little face hugger vial from Romulus, and you may not be able to see that, but he's actually managed to now start embedding LEDs into the 3D print as well. So pretty crazy where it's going, and only made possible because of the embracing of our team of this technology. And the ongoing evolution of both our outsourcing partners through the nylon, carbon fibre-filled nylon, titanium steel printing, large-scale TPU flexible prints, and ever-improving selection of in-house print materials is leading to a noticeable increase in directly printing end-user components, such as the props and puppets we're now putting directly on set into market by cutting out moulding and casting times and cost into our pipeline. I'll just grab this gun. So this gun is from Romulus, and you may recognise it. It's the gun that shoots around the corner. Not sure what you think of that. But this is a rapid-fire gun. It's got an oscillating mechanism. You can see that it counts down as I fire, and I can reset it, and it fires a material out of the barrel to look like smoke is coming out, and the whole gun is entirely 3D printed with 3D printed working internal mechanism components. Unimaginable to us when we were building something like, let's get that on there properly so it doesn't fall off the table, something like the Hellboy guns of 15 years ago, where this gun is entirely 3D printed and tooled, but then turned into elastomeric polymers through complex moulding processes. So 15 years it's gone from that being an extremely complex thing to make to something such as that, which we can entirely now 3D print and put the print on set. Now, it hasn't just been about additive printing, as you've probably seen from some of the videos. And maybe for the mechanical engineering students in the room, I'll turn now to the way we have chosen to also adapt our processes to benefit from CNC via milling, plasma, laser, and water jet cutting. In this case, our journey started with the recruitment of a young Australian guy who had sent me his portfolio 22 years ago. At the time, I was getting over 65 portfolios a week, with people around the world interested in working with us, knowing we'd just finished on LOTR. Although I replied to every submission, and ones of great interest were stored in a specific container within our facilities that Tania managed, this portfolio really caught my eye, and I therefore stashed it upright next to my computer, where I'd occasionally pull it out and look at it and look through it. So fascinated was I by its contents. I had been thinking at the time how we could affordably get into large-scale CNC milling for primarily polystyrene and Suba-tool sculpture. At this point, we certainly couldn't afford any of the machines on the market, so I had set about the idea of us trying to build one. In this portfolio, I could see the merits of someone that might make this possible due to the wonderful engineering workmanship that was in the hobby scale turbine engines the person had been building in the backyard and family garage in Sydney. A year and a half passed after receiving Jordan Thompson's portfolio. I finally picked up the phone and gave him a call, confident in my ability to utilise his backyard build mentality. The chap that answered listened to my introduction and then promptly hung up on me. So certain was he that the phone call was a hoax played by one of his mates. Needless to say, persistence paid off, and Jordan flew over to join us a couple of weeks later. He has just celebrated his 20-year anniversary with us, and in this time, while also contributing to an extensive array of film, TV, location-based experiences, and public and private commissions, Jordan has single-handedly built out our 3D milling department with the custom construction of multiple 3- and 5-axis machines, including the activation of a second-hand ABB as a 7-axis sculpting machine. Jordan acknowledges that his fascination with precision manufacturing started in his early teens, which was likely inspired by his obsession with gas turbine engines and the technical requirements needed to construct such sophisticated technology. This led him to explore a manufacturing world full of extreme precision, automation, metalworking, materials, toolmaking, and highly creative thinking. By collecting as many books as possible and online research, he created a unique vocabulary for manufacturing engineering with no specific training. Ultimately learning about the ability for computer numerical control, or CNC as you'll know it, of machine tools to move, shape, cut, print with innate precision was key to being able to make objects impossible to create by hand or expensive in time and money using other traditional manufacturing methods. It was a revelation to Jordan and to us all to discover it was possible to actually acquire all the mechanical, electrical and software components very cost effectively from a variety of suppliers around the world. To design and build our own CNC machinery that can meet our exacting requirements while costing no more than we could afford to spend, which was pretty much 1/10 of the purchase price of a comparable piece of commercial equipment. There was no question that we would immediately be able to make use of CNC machines for our model making and our engineering work in service to our jobs in the creative industries. And a number of the things that I brought along exemplify this. I think this probably being the most extraordinary example. This is Thranduil's sword that we made for The Hobbit, the role played by Lee Pace. This has been milled on one of Jordan's machines, and when you come up, you will see that it's got a completely hollow hand grip and pierced blade that he has figured out how to mill on his machine. So please enjoy having a look at that. Probably fight over it if you... In Japan, CNC machines are called mother machines, as some of you may well know. And we find this description to be a wonderful and accurate way to name this technology. A similar way to describe how CNC grew to be part of our creative workshop and nurture so many jobs into existence. I have lost count of the revisions of machines designed and put to work at the Wētā Workshop. Each new design was not only built from the lessons learned, but also physically built from parts cut by the previous generation of machines. In the beginning, the first equipment, though crude comparatively to Jordan's build standards of today, was put to work. Thankfully, they made some money, so paid for the improvements and produced precise components for future processes in our business, and helped us assemble custom-designed equipment which could help us improve our processes for the future, specifically catering to the unique and often very organic nature of the products we deliver to our clients. We needed to have a full control of maintenance and customization to match the fast-paced and tight deadlines often required within the film industry. Building the equipment in-house was the obvious choice. Some features we have needed were simply not on offer for commercial machinery builders. As the working years have progressed, we have used CNC technology to help produce armies of soldiers, thousands of physical models, and patterns as part of costume elements, sword making, props, miniatures, sculptures, vehicles, and more recently, our robotic characters and animatronics for our newly established robotics department. We went from basic cutting of soft materials on Jordan's early machines to cutting dies and components with an accuracy of fractions of a millimetre, and now to a custom-designed 5-axis milling machine with a minimum programmable resolution measuring in fractions of a micron. So rock on, Jordan, and a small army of machines. When you are building robots to help build robots, it doesn't really get better than that, I figure. So you should have seen in the slides above me a number of images of the humanoid robots that we are building. These we are calling the Wētā series, and we've moved through Wētā 001 and now we're at 004 over the past 4 years, with Wētā 005 coming online and intending to be our hoped-for productization of our first commercial robot. Maybe not surprisingly, this is much, much harder than it may seem. If we consider that the Disney Imagineers are probably the world-leading builders of animatronic humanoid figures, where they have a 60-year legacy of building aerospace quality robotics to drive their characters in their parks and build them to be relatively maintenance light due to their build methodology of constructing most mechanisms with highly spec'd, very solid construction approaches. Of course, the bigger the mechanisms, the heavier the load, requiring larger actuators to move around these sorts of masses. Larger actuators cost big money. So if we are to find a way to establish a client base, then we need to build our robots with a different build methodology in an effort to try and keep costs down and speed of production assembly up, therefore having a point of appeal that hopefully will win us some clients. So why robots? I tend to worry that as a team within the workshop, we could run the risk of hitting up against our own ceiling from time to time. It would be fair to challenge me on this, as every year our team are pushing the innovative bounds of what we're trying to do at a technology, materiality, design and human resources level as tensely as we can. But regardless, I feel that we need to keep finding new North Stars in the workshop, and that the crew can get in behind and try and create results outside of our existing skill levels and our capabilities. This way, we're constantly challenging ourselves to be at the top of our game. And even if we're trying to do things that only a portion of the company are participating in, at least we can create an endeavour where everyone is aware of the undertaking and can see the role, the toil that is going into this, and hopefully be inspired by their colleagues' efforts. We have always created animatronics. I brought some along with me today for you to see, and mechanical controls for our puppets and props for the film and TV industry. Some of the first puppets that Tania and I built back in the 80s, sculpted in margarine, cast in rubber latex, with roll-on deodorant balls for eyes, controlled by fishing line, running through that springy cable that used to be used for hanging frilly curtains in Grandma's kitchen. Firstly used on Public Eye, the New Zealand version of Spitting Image, and then developed further with the team on Meet the Feebles and Brain Dead. It's when we got on to Hercules and Xena that we began building creatures for these two shows that we really started to develop our radio-controlled, servo-driven capabilities. Over the years, we've also dabbled with pre-programmable puppets, So when we'd arrive on set, the puppet would already be capable of running through its performance and lines. But this has always been in a film set environment where we can nip in and make changes and repair as needed. As you can appreciate, it is a whole other thing to be building long life, constantly performing humanoid robots for the themed entertainment industry, where the expectation on the robot to work every day in and out without a hitch. It requires a whole other mindset and a significant amplification of the tools and capabilities from what we have been used to. But this was exactly the sort of thing that we can challenge ourselves with the hope of pushing the ceiling up for another year or two. Now, back in 2019, we made the decision to build an immersive walkthrough experience in Auckland called Wētā Workshop Unleashed, a fantastical film effects experience, where we hope to inspire our guests to make and create by taking them through a guided walkthrough experience where we inspired and demystified the processes that we use to make practical effects for horror, science fiction, and fantasy filmmaking. As we were our own clients, we could choose what the content of the experience would be, and one of the items I was adamant that I wanted us to build was a fully autonomous, talking, performing robot in the form of Jeff, our receptionist and security guard. Only Jeff is an orc. We built Jeff over an 8-month period, and today Jeff has been meeting and greeting our guests multiple times every day for the past 4 years. He runs for 4 minutes every 15 minutes, telling really bad dad jokes, warning our guests of the dangers within the workshop, and generally making mischief. Jeff has become a much-loved member of our crew and gave us the confidence that we could forge forward with the aspiration endeavour. Jeff is Wētābot 001. So here's a general overview as what has been our thinking to get from Jeff to Wētābot 005. Firstly, the motion of robotics. And of course, the most critical consideration, because without quality motion, it's just a bag of nuts, bolts, and nicely made componentry. So key to the approach we are taking is trying to abstract the specific technologies from the aim or the goal. We're trying to build a system for taking motion from anywhere and applying it to any robotic configuration in an ideal world. As an example, 004's motion is a mix of body motion capture, a base layer of idle facial motion capture, eye line from the body mocap, lip movement from a neural network input that we've developed, as 004 needs to speak multiple languages, and facial motion from an actor using a cell phone, all mixed in with a manual adjustment on site, all of which runs through a custom motion editing setup we have designed in-house, similar to video editing, only in 3D. This is important for us because we believe that tying one work to any specific technology today is a poor idea, and is only going to get worse as the speed of technological advancements increases and increases. You can effectively bet on the wrong horse if you're not careful. For us, being able to mix data is so important, as we can incrementally add technologies to our animatronic movements, e.g. a system for collision detection could adjust baked animation on the fly, or an abstracted balance routine could adjust manually animated data, similar to what we're all seeing from Disney's latest research. So generally speaking, developing our AI capabilities plus neural network technologies, allowing us to bridge the gap between procedural robotic motion and character-filled human-made animation, which is an exciting place to be. Typically in 3D animation, the two approaches are very far apart, with pluses and minuses to each. But of course, the client wants the pluses from both sides with none of the minuses. So we see that the introduction of AI has the likelihood of making this more possible in the future. And from a build methodology, knowing that we can't go down the heavy engineering, high-spec, large and powerful harmonic actuator path with extremely expensive R&D phases, we've had to come at it from an entirely other side of the build perspective. Very light engineering, utilizing additive printing and lightweight actuators, offshore inexpensive manufacturing processes, and really careful iterative design advances utilizing our knowledge in 3D prototyping from our film work to advise our test till it fails approach. For instance, the neck mechanism of 005 has gone through 26 iterative prototypes, each a minor or radical adaptation on the previous mech, due to the fast turnaround ability to print new components at lightning speed. And to be honest, we still aren't satisfied. For the iMech alone, we've produced multiple iterative test models, learning from each variant in producing in weeks-long prototyping phases, as opposed to what could be multiple-month endeavour if we were working in more traditional methods. And I actually brought one of the multitude of eye mechanisms that we have created to test different configurations of eyelid to servo to lever arm work. We can turn around a prototype such as this in a matter of 2 days, where once this would have been maybe a week and a half's work due to the ability to rapid prototype solutions. Our robots have 60 points of articulation. This is a very ambitious, with each new point being a potential point of failure, and all the componentry needing to be squeezed into the human frame. But our objective is to try and capture the qualities of life in the faces and bodies of our robots that we are building. We realize that we have a hell of a long way to go if we are to reach this goal, but each iterative step forward brings us closer to achieving this. A critical factor of humanoid robots is the integration between the hard mechanics and the soft skin. This is a multi-material challenge, and one that can't be underestimated. Even though we have the ability to create hyper-realistic replicas of human beings at the workshop for static models, producing a skin interface with the mechanical pickups of a robotic face without the utilization of any glue, as the face needs to detach in seconds and reattach in minutes for maintenance reasons in the parks, this makes the fabrication of strong yet flexible, elastic yet stiff, realistic yet mechanical, skin-like silicon incredibly challenging. It requires our prosthetics and creature technicians to have a strong appreciation and a mid-level understanding of the requirements and limitations of robotics, while the animatronics engineers need a respectful understanding and interest of the finer points of silicon skin making. The trickiness of this interface cannot be underestimated, and we strive to keep the relationship between the two areas of expertise as fluid as possible in the pursuit of the best solution we can achieve. As you can appreciate, all of this is extremely unforgiving, as any small defect is easy to see, and the most undiscerning audience member can still catch the shortfallings and nuances of a face or body that simply just doesn't look real. I'll mention an interesting sidestep that we've taken recently, and this is the use of live performance telemetry system that we have developed for our Jeff character. We wanted to take Jeff out to tourism conventions to help us promote our tourism offerings. We, of course, could have used the pre-baked animation pipeline of Jeff at Unleashed, but we really wanted to find something that could be a little bit more compelling in the one-to-one interactions with the public than this. In the absence of a highly developed AI voice recognition and response engine and super fidelity eye tracking capabilities built into the animatronics, the option that we chose for development was the use of a MetaQuest Pro VR headset for tracking facial, eye, head, and body movement. And we're working on the arm performance at the moment, while utilising a combination of Unreal and Blender to enable and smooth out the interactions with the guests. We have given Jeff the choice of a trucker's cap or a cheese cutter hat, depending on which type of function he's attending, so that we can embed a low latency camera hidden in the brim as a way to give our actor playing Jeff direct vision to the person engaging with him. We also use a low latency microphone so that the actor, hidden in a room off-site, can hear the questions from the audience. So ultimately, a fun and engaging way to connect with an audience in a live environment. Jeff has thus far been away on 2 outings, and the results have been hilarious. Many people that interact with Jeff immediately assume that he is a sophisticated AI. And a certain government minister who was visiting, when introduced to Jeff, immediately asked, "How is he working?" with the attendant explaining that there is in fact an actor performing the character, to which the minister explained, "There's a man inside him?" We've heightened this level of confusion by also positioning one of our tourist staff within earshot of Jeff. This person happens to know most people operating in the tourism trade in New Zealand. So when she sees a specific tourism operator curiously choosing to check out Jeff, the Jeff puppet, she quickly whispers in Jeff's ear so that the actor playing Jeff off-site can hear her description and input before she fades back into the crowd. So when the person walks up to Jeff, he can immediately greet the individual by name and ask questions about their business. "Hey Bob, how's it hanging? How's the shot over jets working for you out of Queenstown? Life good?" For example. Needless to say, a few of our guests have lost their minds. Of course, our ultimate objective is to develop a AI for Jeff and our other Wētā bots, so they can respond in real time to our audience. We have made some very preliminary endeavours in this direction, with our early tests getting Jeff self-aware enough to make a few really bad dad jokes. So when our Jeff 2.0 got asked recently what he thought of me, he responded saying, "The boss, he's a bit awkward. See what I did there? I'm an orc, and the boss is awkward." So he's becoming self-referencing and trying his hardest to make a bit of a joke. It's early days yet, but to the limit of our available resources and R&D budget, we'll try and push forward with this, as our hope for our future robots is to create deep connections with our audiences through their human-like movements and personalities, and this is incredibly exciting for us all. And just jumping back a moment to the additive printing comments of earlier for the 3D printing note takers in the room, the evolution of our 3D printing across our robots started with heavy use of the Prozone green resin, which surely many of you have been using, but found that this is vastly inferior to the sintered strong as nylon and doesn't hold up to the elements. So this led to a reliance on outsourcing parts being produced in powder bed nylon printers. And we have moved to largely prototyping and ABS on our new bamboo printers, and still having to outsource our finals. With the introduction of TPU, the material I mentioned earlier, our materials library has begun producing more bellows and flexible covers in this wonderful new material. This similarly started prototyping for powder bed outsourcing parts and has moved for largely in-house production with Varisa Shaw materials. Once the Nexa was on board, we have slowly been producing more and more in-use parts in-house. I think there's close to a 50-50 split now in terms of the outsourced parts on animatronics as what we can do in-house. As we don't own an SLM, which is a selective laser melting machine, and sintering machines, we outsource all of our metal printing parts in China with exceptional results. I brought along, these are pieces that we are manufacturing outsourced from China, really beautiful, exceptional pieces, and those engineers in the room might enjoy coming and seeing those. And most of our requirements we get printed in China with exceptional results and exacting tolerances. This is increasingly cost effective as well as freeing up the machining constraints of CNC. But we're still learning how to adapt our processes to the idiosyncrasies of printed metal. So in conclusion, and to share some thoughts to the students in the room who may be focused on a future in the creative and technical industries, and this is only from our experience, and you may choose to take other experiences in your future life. But from our experiences, we believe it is very important to be as multi-skilled as possible. We strive to understand the challenges inherent in the wider project, so your part of it has relevance to the overarching endeavour, and to be able to offer solutions outside of the box because your wider understanding of the overall project. Never overlook the low-tech solution, down to hot glue and popsicle sticks potentially for prototyping when required. And never be afraid of multiple iteration prototyping as early as possible with the same low-tech methods. Quickly move through fast-fire prototypes to explore as many ideas as possible while confirming the ones that don't work at all. And try not to work on massive digital processes like PCB, printed circuit boards, design, mechanical design, and software design without testing individual components one by one and implementing them gradually into the full design. But also, in contrast maybe to the hot glue and popsicle stick mentality, also consider moving quickly to a test phase by using your chosen low-cost manufacturing process. This will give you a visual over the final product outcome at relatively low costs. It will help you solve bugs inherent in these low-cost solutions, such as electronic breadboards and weak 3D prints. Always be aware of shipping time. We are not in the right country for next day or same day delivery, and this can easily grow to multiple weeks and months and completely scupper your deadline. And assume that most commercial products might potentially be faulty. So you do your own QC testing to check the certainty of your purchase components, and don't risk them failing when installed untested into your build. And most importantly, remain bright-eyed and bushy-tailed. Regardless of how deep and how complex the project may seem, come at it with an unabashed enthusiasm and an inquisitive mind. And I operate by 4 very simple tenets. Maybe a little trite to share with a group of engineering-minded audience members, but at the risk of sounding corny, love of oneself, love of what you do, love of who you do it with, and love of who you do it for. Without these 4, I'm just not sure it's all going to be that much fun. So thank you very much, and a pleasure sharing my speech with you. And it looks like we've gone through the question and answers piece, but let's turn the floor over now to Q&A.
Thank you, Richard. What an incredible story. I'll ask David Hopkins to give a formal vote of thanks in a minute, but first, we've all marvelled at your ability to transport us into a hyper-reality or fantasy through your movies, but the opportunity to have the behind-the-scenes story and from you this evening is most appreciated. Thank you.
Thank you.
The sheer scale of what you've achieved is hard to process in the time we've got this evening, but I'm sure there are many questions out there. Could I just ask for the house lights to be lifted, please? Thank you. We have 4 roving microphones, so we are recording this evening, so if you wouldn't mind waiting until we indicate that we're ready to take your question, we'll do that, please. And just while we're doing that, as Larry mentioned, I'm Andrew Lamb. I'm proud to represent Canterbury branch of Engineering New Zealand here. We have 4,000 members in Canterbury and 22,000 nationally. It's our pleasure to support this lecture each year.
As I said earlier, there's some questions I may not be able to answer for you because your technical knowledge may be greater than mine, and I'm very quick and willing to acknowledge that if I can't. If you really want an answer to the question you've asked and I can't answer it tonight, please come and see Tania, my wife down here, who will hold up her hand. There she is. And she will write down your name and connect you to the right person in our workshop that will be able to answer your question, hopefully. And may I just make the point that when Jason talked on the stage, he brought Thingy, so I thought I'd better bring a face hugger.
Do we have questions?
Can't be this easy, can it?
Up the back there.
Hello.
Thank you so much for your inspiring presentation. I don't have a geeky, techie question. I'm a Kiwi, I went abroad for 10 years and I came back, and there's a lot of talk about the brain drain in New Zealand, how a lot of talented Kiwis are going abroad and not coming back. But I just wanted to know how many people in the Wētā Workshop, you said there were about 400 staff are internationals. How much Wētā Workshop drawing international talents into this isolated island of New Zealand?
Thank you. That's a good question, actually. At the time of Lord of the Rings, we were 100% Kiwis, and we brought in maybe 5 people from overseas. Only one of them was actually an expert specialist, a guy called Gina Acevedo, who's become a great friend of ours and now works at Wētā Digital. The rest of them were young people just enthusiastic to come and join us. We couldn't find people for love or money, which is hard to imagine today, but people really didn't trust that this was a real thing and was going to happen. But today, probably a third of our crew is from overseas. Almost none of them we've actually recruited from overseas. They're people that have found their way to New Zealand. They've popped in to say hi and just never left. And that literally is the reality. We have 2 Argentinians that are working with us. You may have seen some of the beautiful little sculptures called mini epics. I believe there was one of the character out of Labyrinth, and Sarah out of Labyrinth. And those 2 were travelling down country, Horgalina and Mauro. We didn't know them from a bar of soap, and they just called in because they were fans of Lord of the Rings. And they have been with us 14 years, and they never got any further than Wellington. So that sort of just happens. It's so relevant, so dependent on how busy we are at the time. Our work fluctuates very dramatically, which is scary for us, especially as Tania and my primary objective is to try and offer certainty to our crew. This is a very uncertain industry. Obviously, COVID had a very dire impact on the entertainment industries of the world. But the strikes that happened in LA after COVID just doubled down on the pain that the other 9/10 of the world's film technicians have felt because of those strikes. So it has been a very interesting journey. And the certainty that we want to offer our crew, whether they are from locals within New Zealand or from overseas, is the most prevalent thing that we're trying to achieve. So the cyclic nature of our work can be very challenging for people desiring to work in the creative industries in New Zealand, specifically in the film industries. But we're very lucky to have the combination of people, both local and foreign, that we do. Thank you.
Thank you, Richard, for showing a little bit of the magic behind the curtain at Wētā. With creative teams, you have people from a whole lot of different backgrounds and skills trying to work together, and in that kind of work, having a shared creative vision that everyone believes in and is clearly communicated is really hard. What's the secret for Wētā to try and get everyone on board with the vision?
Well, as you can appreciate, it's not for everyone. The myth often can be greater than the reality. I would say that's the case with almost every industry anywhere in the world, no more or less so than our industry. Some people it perfectly suits. We've got people in their 60s that have been working with us for over 25 years who have been lifers at the workshop. Over 15 of our staff have been with us over 20 years and probably will always be with us as long as we can try and stay in business. The reality is, though, that some people join us and discover this isn't for them at all. It's intense work, it's hard work. We do try and stick to a predominantly 42.5-hour work week, respectful of the fact that people now have families and other interests, but it is hard work, and for the hours that you're in the building, it comes down to a dogged determination, a self-belief, as I said, love of oneself, love of what you do, love of who you do it with, and love of who you do it for, right? You've got to have a respect for the fans, for the audience, for your clients. That's a love of who you do it for. Love of who you do it with is the people around you. You have to respect and appreciate your colleagues. If you're to go it would be just easier to go and do something much, much easier than this if you can't find a love of your colleagues. And obviously love of what you do. Whether it's the tedium of hand assembling, this actually is 3D printed chainmail, because I was trying to make a point of 3D printing, but even whether it's someone hand assembling 12.5 million links of chainmail on Lord of the Rings, for 3.5 years he never raised his head from the focus required to achieve that job because he loved what he did. And that is something that we find in the passionate individuals that come and join us. On Lord of the Rings, I came up with an expression, a little bit wet, but no matter how fine and how faded the thread that you are given, if you don't weave it into the tapestry with love and care, in some way the tapestry will be threadbare. It's very similar to you're only as good as the weakest link, right? It doesn't matter how small or how grand the job, if every individual can do it to the best of their ability, hopefully we can achieve what we've done here. Tania and I don't have any training in business matters. We've learnt on the job. And so we are very much of the view that you basically run your business by leading by example. If I go into the toilet and it is unclean, I will clean it before I leave the toilet, because I consider that it is my role as much as it is our cleaner's role, because it's there to be done. And as you can probably see from the images, I try and be as involved in as many things as I possibly can every day. And by doing that, you are able to show by example the expectation that you have of the people that work with you, and hopefully they follow in accordance. But we have incredibly mature, incredibly dynamic, incredibly inspired people that that for the most part are so integrated into the challenge of the day that it just comes naturally to them that they will do a great day's work and deliver a great product at the end of it. And that's something that we constantly are very thankful for. So, thank you. Yes?
I want to ask you
the mother whose son Michael is at home poorly and asked if I would sign his book.
I just want to ask, you must experience many challenges and difficulties, and you brought a lot of good stuff here today. Which one you're most proud of? Question one. And question two, when you face challenges and difficulty, how did you turn the situation around and make it happen? I can tell that you're a person, you won't take a no for answer, you go for it. Share that with us. Thank you.
Thank you. It's hard to call out any one thing, and nothing that I've brought along today would be one of my favourite things, because they're all parts of processes. The thing that I think that I'm most proud of is the ability that we've had to empower a disparate group of young New Zealanders to believe in themselves enough that they can achieve the extraordinary things that we've done. That doesn't entirely fall on Tania and I, that falls on all of our senior team. Even it falls on the friends and colleagues of the young people within the workshop who support and lead people that may be lagging behind forward into the fray. We try and always push for the best we can possibly do. I'm the first to acknowledge that we're not the best in the world at what we do, but we certainly strive to be the best we can be in the world at what we do. And they're two very different things. And so if I think about the thing I'm most proud of, it is the achievement of gathering a group of people around us that have craftsmanship and creativity at the forefront of their lives. You know, many people in the room who grew up aspiring to be artists that are of my generation were told by their mums and dads, as I was, there is no future in the arts, son, right? There's no future in the arts, dear. Don't waste your time with that. It would be better if you pursued an engineering degree or, an accounting diploma. But for those of us that do have a creative spark burning within us, we can't be told that. It's imperative that we are given the ability to pursue these things. And you would, I'm sure those in the room that are from the engineering faculty here appreciate that probably the greatest core attribute that you have is your creativity. And your creativity to look outside the box, to think differently, to break the rules, to achieve things in a new and dynamic way. And I genuinely think that, that if you think about it, other than Mother Nature, isn't almost everything that we have and do in life some way touched by a creative hand? If you think about it, the clothes you wear, the car you drive, the house you live in, everything within the house, everything that exists within every interface on every piece of digital technology, every book that you've ever read, every dance performance you've ever gone to see, the graffiti on the walls, the tattoos on the arms of the kids in the cities. Right? These weeds grow unhindered through the urban pavements of the world, and it's not for us to try and chop them off. It's for us to celebrate in them and be inspired by them. So I actually think, in detriment to our parents' generation, there is the greatest future should one choose to follow the arts, and that is something that I'll continue to speak out on for as long as I can live. So, yeah. Thank you.
Hi, thank you so much for your talk. I was wondering if you could talk a little bit about the sort of process of art direction and what happens when, I suppose, a filmmaker approaches you and wants your help in producing a film. And as a follow-up question to that, has there ever been any situations where you felt perhaps a bit of disagreement with the sort of creative visions of what you're being hired to do?
Yeah, great question. Look, it's slightly semantics, but just so no one's got any confusion, we don't produce films. We're not filmmakers, and there's often some misunderstanding that we are integral to the creation of the film. We are service providers on films. Now that may mean in some cases that we're an integral service provider where a client may approach us with a napkin drawing at the very inception of an idea. Or we receive a fully fledged out script that has 30, 40, 50 other service providers working on the movie, and we're one small component of that film. For Romulus, Alien Romulus, we did the guns, some other hardware, the mechanical face huggers, a small component in a masterfully made and grand film. But our interface with the director is a very varied one. I love that phase of a project. I pride myself on the fact that our senior creative leads have become extremely skilled at playing that role alongside me and regardless of me. There's many movies that we do every year where I have a very minimal touch point on it because I've got other projects that I'm running and just simply don't have the time to have that level of relationship. But getting into the mind of the director's vision is a critical thing, and that comes down to one element above all else. And I know it's a well-worn adage, but that's listening. It's so easy not to hear what the director is saying. Some directors it doesn't come naturally to some directors to be able to describe things visually. They may have an extraordinary ability to direct actors and tell incredible narrative through their filmmaking, but they may not necessarily have yet made a movie that requires the sort of stuff that we do. So it's imperative, therefore, that in the discussion with them, we glean the necessary hints towards what they're actually after. I've said more than once that a really great thing that could come into the film industry is what I've called the annotation of scripts, right? A script writer will spend 6 months, a year, 2 years, 5 years writing a script. It would take maybe only 6 more weeks to annotate the script and in the borders of the script actually note what they are visualizing when they're writing that line of text, right? So that people like us and other service providers that have to physically manifest those words of text into actual items could at least get a suggestion before we start on what was being imagined at the time the line was being written. Might be too much to ask, but I've always thought that might be a sensible thing. I'm sure Jason actually would agree with that. But that's a reality that I haven't yet seen. So the first meeting, that first initial discussion becomes so critical that you listen and hear. I often will whiteboard frantically on a whiteboard in our conference room while the director is actually talking, trying to capture ideas alongside the discussion. Other members of our crew have other techniques that they use. When we first went to Peter Jackson's house on the very first day that he wanted to tell us about Lord of the Rings going to be made, we returned back to the workshop and one of our staff called Jamie Bess-Warwick, who was only 18, 19 years old at the time, went into a frantic, intense 7-day sculpting session So the next time we went and caught up with Pete, we returned with a large collection of maquettes. A number of those maquettes, of those sculptures, are seen in the final film, unchanged from Jamie's original inspirational collection of ideas, because he listened to Peter's inspirational descriptions and was able to capture them three-dimensionally into plasticine. And if you were to hold up that maquette against the final image on the movie made 5 years later, they would perfectly correlate, such as the accuracy in which he captured that vision. Doesn't always happen like that. Sometimes you may do hundreds of drawings, dozens of maquettes to try and find the right idea. But more often than not, often your first inspirational thoughts may have captured what the director described. I just quickly make a mention, about 50% of our work is in location-based experiences. That's Gallipoli, the scale of our war, the traditional Chinese medicine museum, the huge atrium for the shopping mall, the Dubai Expo, Le Quemois, etc., etc. The beautiful thing about that work is that unlike film, when you build something, it always goes through someone else's filter, almost always for the better, right? The director will take what you've created and through the magic of their craft will put it into the cinematic experience in a way that enhances what you've created through the lighting, the atmosphere, the interactions of the actors, etc. The beautiful thing for me, and the thing that I love so much about working in location-based experiences, is there is no filter. There's no filter at all. What you build is seen raw by the audience. There's no ability to cheat the eye, to redirect the observational gaze of the audience in the way that you can in cinema, where the audience is locked into a single point of perspective looking at a flat movie screen, and your directorial skill defines how the audience goes along the narrative chain. That doesn't happen with LBEs. The audience have a choice to look wherever they wish. So your work is seen entirely raw in front of the audience. And I love that. I love putting my neck on that particular chopping block and hopefully getting away without losing my head, because it adds an unbelievably defining edge of the knife blade quality to the work, and something that I tend to thrive on in the stuff that I love to do today. So hopefully that answered the question. I sort of forgot the last bit of it, but hopefully that will do. Yeah, good.
Thank you, Richard. Just, Rashmi, I think there was a girl behind you, just on the aisle, who had a question. Yeah, thanks. Behind you, did you have a question? No, the girl. Yeah.
Oh, spotted.
Hi, sorry.
Hello.
Not the most interesting question, but when making the props, what was your most difficult or like longest project when making something?
Any ideas? They all tend to roll into one. It would surprise you that a lot of the projects that we do, although they may have very extensive design and development periods, sometimes they don't, but mostly they do, the actual approval to begin manufacturing happens in an exceedingly short length of time. We've done many projects that have had no more than an 8-week manufacturing period, where we've produced many hundreds of weapons, dozens of suits of armour, prosthetics, etc., in a very, very short length of time. I mentioned The Hobbit as having a very condensed pre-production phase. That was no fault of anyone's. It was just a series of events out of anyone's control that meant that by the time we finally got to start manufacturing, the time was whittled away. And that required us playing catch-up for the next 2.5 years, to make sure that everything was ready for the day of set that it was required. But there has been projects that we've done that have had long build times due to their extreme complexity. You would have seen a car on the screen. It was the sort of wedge-shaped car. That's for a film that's just come out called Foe. In contrast, when we did the Warthog for the Halo shorts that Neil Blomkamp made after the Halo movie fell over, we built that Warthog. It was a fully working Warthog. Those of you that play Halo know that the original Warthog has a wishbone suspension. We didn't achieve that because it's just too dangerous when you actually think about it from a mechanical car construction perspective, and we could have a whole debate on that if anyone wanted to. But other than the wishbone suspension, the car that we built could achieve pretty much everything that the Warthog could. It had 2-wheel, 4-wheel, and crabbing ability. So 2-wheel, it drives just like your car. 4-wheel, it means that it can turn almost in its own length because its wheels can turn independently to each other. And then it could crab by its wheels turning sideways. I went up Park Road at 100 kilometres an hour sideways in the Warthog. Very stupid thing to do. Not as stupid as Jordan Thompson, the guy I was telling you about that built all of our milling machines, and you can actually find this online, actually built a jet-propelled mechanism which he strapped to his 10-speed bicycle with a 2-litre bottle of rocket fuel between his legs, controlled by a servo control mechanism which required him taking his hands off the handlebars to trim, and he managed to dry the water on the wet road as he went up Park Road overtaking other cars. Now that's stupid, but got on Jordan. And the Warthog had 4-wheel independent rock climbing ability. The chassis was an air cylinder, all control within the cab. It had a working rotary minigun on the back. It could go 100k in mud, which was one of the requirements of the client. You would have seen it smashing through the brick wall, so it had to be able to do multiple impacts against very hard surfaces. And we built the whole vehicle from very, very first moment discussing it with the client to delivery on set in 6 weeks. 6 weeks. You're bleeding from your eye sockets, but if you say no, some other company would get to build it and you'd lose the opportunity to build a Warthog. So you basically rally the troops, you ask everyone if they're up for it. Some people aren't, most are, and then you build a Warthog in 6 weeks. In contrast, that wedge-shaped car, which was an incredibly complex build, one of the most difficult things, as those of you in the room that do car conversions, car refits, etc., you would have seen the sliding doors that run parallel to the car and they suck in and lock into the door jamb. That was hard. And we folded it all out of aluminium. We built the chassis. It had full suspension. It was full electrically driven, full lighting system, full dash system. There had to be a self-driving car, so we had to be able to hide the driver inside the car. Due to Australian film laws, we couldn't operate it off radio control, as you would naturally think we would. So we had to actually bury a line-of-sight driver inside an artificial seat, the way you see smugglers getting over the borders of the world. We copied exactly that. We found pictures on the internet and built an identical seat, and it works really well. But that's a good example of a project. I think we had 6 months on it. I'm just looking down at my family who both helped on it. We had 6 months on that project, and that's luxurious on any one project. So hope that's a good answer to what you thought was a simple question, but is a great question. So thank you.
Thank you.
Thank you. I'm sure there will be many other questions, but we do have a light supper available outside, and at some point we have to get Richard off to a well-earned meal. So I'd now like to ask David Hopkins to give the vote of thanks.
Well, kia ora tātou, and good evening, ladies and gentlemen, and for those in the spare room and online. I think we've had you will all agree, no one will disagree, a Hopkins lecture like no other. Richard has certainly shattered the previous record for a number of slides shown during an hour and is unlikely to be beaten any time soon. But first of all, before returning to that theme, I'd like to thank you all as our audience for this Hopkins lecture, wherever you are. It's greatly appreciated by the family to have the memory of my father captured in this way and commemorated, so thank you. And in that same line, thank you to Larry and Andrew Lamb and the University of Canterbury and all those Engineering New Zealand who make this lecture possible. Again, it is deeply appreciated by us. And I mention those David Elms, who may be here, I didn't see him, Toby Richards, Brian Wood and others who set up the lecture long ago in 1978. Tonight's speaker really has reminded us of the joys of creativity. I'd pre-prepared some analogies between the creativity of making things out of steel and concrete with what we saw tonight, but I'm really not going to extend any further into that. But it's been an extremely rare privilege, Richard, to see you operate under the guise of a Hopkins lecture, to share your wonderful success, your achievements, your insights, and your wonderfully articulate way of describing these things. It's no wonder that you've succeeded like you've done. Did anyone guess the title of this lecture? Did they have to read it again just to check? The joy of creativity? It actually came through without any words from you. And I've written down here, not just a successful person looking back that we heard from tonight, one who is looking forward to the next developments, as we heard in his question, as he answered the question. A 59-year-old geek, prodigy, determined not to grow old, seeming as what I thought, but a brilliantly successful business leader, and you can see the reasons why. And summed up in his mantras, love of oneself, sounds a little bit selfish when it's said on its own. Love of what you do, love who you do it with, and love who you do it for. My goodness me, I think if we all went away with that sort of thing in our mind, we could make a lot better effort and outcome for a lot of what we do. How many others made notes of this presentation, as I tried to do? What a dumb idea that was. So, Richard, thank you so much for giving the 2024 Hopkins Lecture. Now, I've got a token appreciation, and one of the things is a book called Stones of the Arch. During COVID, I made this book from writings of my father about Roman stone arches. It's called Stones of the Arch. And it occurred to me when listening to Richard that if the Romans had only had 3D printers, they would have made them out of that. So once again, please join me in thanking our speaker for his most brilliant Hopkins lecture.
This is a beautiful book to give me.
I'll give it to you now and you give it back later. If you've already got it.
No, this is a beautiful book to give me. I do a lot of stone work in the region. Thank you. That's it. Of course, none of it is possible without the person next to you, and that's Tania right here. So lovely of you to give her a clap too. Thank you very much, everyone. I've thoroughly enjoyed talking. I don't normally read off notes because I've got it all in my head, but when I was asked to talk to the engineering faculty and other engineering professionals, I ran a bit cold, so I decided I better write something. And so you got a very rare speech from me where I'm actually reading off notes, which my wife is, you sure you can do that? But because you're normally just talking off the fly. For those that want to have a look, please come forward. We probably can't accommodate too many people, so if you're not really interested, don't. But the engineers in the room might like to come and look at certain things. I'm happy to answer any questions about what we've got here and share a little bit. I know that I've got an appointment to get to a dinner with the wonderful faculty that have hosted me tonight, but I'd love to tell you anything I can if at all possible. Right, thank you. Sam, maybe you could help me carry this down.
So just before you go, you are welcome to join us outside for a light supper. This lecture has been recorded this evening, so it will be available on the civil engineering website, so please feel free to share that.